All right, what's up, YouTube? I spent over 12 months trying to learn to code on my own, following the self-taught path. I got 0 job interviews. I thought maybe I wasn't smart enough to build this stuff. And eventually I did the same thing as every other failing self-taught programmer. Just spent all my money on a boot camp. In this one, we're going to go over how I learn anything now. So a few years after learning to code and finally landing my first job, I wanted to go down a path of learning something even harder than coding. For me personally, I'd always been interested in foreign languages. Japanese, it's known as one of the hardest languages in the world. So to do this, I didn't want to just jump in blindly, and I went down a process of learning to learn. It actually taught me a lot about myself and my learning techniques. And eventually I got to a point where I was able to pick up anything rather quickly, and it made me just more efficient with my learning. So rather than just jumping into this educational content for coding, you would jump into coding tutorials, or you jump into some videos, or eventually try to build something yourself. I went through this process of learning different learning methods and different things you try. This fundamentally changed how I learn anything. It wasn't that these tutorials or videos were bad. They were great tools, but you're not learning anything. You're just learning keystrokes on a keyboard, and you're learning how to copy someone. So now we have all these AI tools. I want to take you through how I would learn to code, and I call it learning to code with immersion-based learning. I hope you guys find this useful. This is my adaptation of a known process in Japanese and language learning in general. To go over this, we need to go back a few steps. So I do apologize if you want to get straight to the coding stuff, but that's not going to happen until at least a little later in this video. We need to understand some fundamentals of how this method works to then understand how it affects us in software development. We need to talk about the old way of learning. And the old way of learning was syntax first. And what that means is basically you would find someone's tutorial, you would follow that tutorial, and you would type exactly what they type, but you don't actually learn anything. You just learn keystrokes slowly over time. And it's not even an efficient way to learn keystrokes. You're trying to copy someone that is already efficient at doing that thing. So what I was doing was I would watch 30 seconds of a video, I would pause it, and then I would jump between the video and my IDE, and I would copy exactly what they did. And I didn't actually learn anything. All I did was I would learn to copy. It wasn't learning to code, it was learning to copy. So the problem there is that when the video ends, you haven't actually done anything yourself. You've copied someone else's keystrokes, you've learned some syntax, but a poor implementation of that syntax. You haven't actually learned how to code or how to put these things together. Once you'd learned that part, you'd think, oh, I'm not learning much from these free videos. Maybe their free courses or their paid courses are going to be more educational. So you would go and pay for a course that was basically the same thing. That's exactly how I learned to code. It's not to say that it's bad. I am definitely not discounting what I learned from those courses. I got a lot of exposure and I got a lot of different ways of doing different things from them. And I do think that that is a fundamental step. It will not be replaced by this method. It's just a supplementary to this method. This will be your main method of learning, but you can use courses and other people's learning methods as supplements to this. Then they realize they can't code. They realize all they've done is learn how to copy. And that really disheartens people. It's like, you want to build something cool. You're trying to learn a skill. You're not actually learning the skill. You're just, again, you're learning to copy someone else. So I completely understand this feeling. I felt the same way all the time. And even once I went to school and was in a group with other people, the first few weeks was brutal. And I had a good fundamental knowledge of software. I was at the top of my class and I was still very overwhelmed because I'd learnt the wrong way. What I learnt from going to school was that it was very much the same in that we had a teacher that would teach us how to do the syntax. They'd be like, oh, you need to do this thing. And if you do that, you will get a variable, you'll get a function, you'll get a loop. Well, that's a very straight line. But you would learn the fundamentals, but then you were forced as a group to actually build something. There was more accountability on that. You had to solve the problem yourself or you were going to fall behind. And I think that's the only reason that those sorts of things are successful. It's got less to do about the learning style and more to do with the forced repetition and the forced learning that if you don't do it, you've wasted all this money and you're going to fail. Now we're going to talk about what's changed in this loop. And I'm going to try to not cut off any of the text here, but yeah, we'll see how that goes. AI has fundamentally changed this learning loop. People have not grasped this yet, but hopefully this video will help people understand how AI can still help you with this. So before AI, we would write code that we didn't understand. We would build projects that we didn't understand, and then we would try to learn from that. And a lot of the messages we would take away was around this step. We learned a little bit of syntax, but again, because we were copying other people's syntax, we were learning to copy at this step. But a lot of what we were learning was this building, things like different file structures, different build processes, different packages you could use. We weren't actually understanding how the code was written and the formats that it was written and why. We were just understanding the build part. And again, that's not, I'm going to say it 100 times, it's not a bad thing. These are fundamental things that you do need to learn. But the focus was on syntax over functionality. The thing we need to change in this process is syntax. Before, if you wanted to, oh my God, these lines are perfect. If you wanted to use SQL, you had to learn SQL syntax first. If you wanted to use JavaScript, you had to learn JavaScript syntax first. And the IDE came a long way. It gave us autocomplete. It gave us a lot of things that really helped us, but it never really was as good as it is today. So you couldn't write full definitions. You couldn't do full feature implementations with AI. So you had to have an understanding of these things so that you could write these things. And now what do? Well, I don't know about you, but AI writes a lot of my code. I mostly am there to architect what it builds, and I'm there to review it. And what does that mean? That means that the building is done. We can essentially skip to this point. We can be like, okay, we let our tooling build things for us. Our process is to understand the messages. So we take what's been built and we understand what's been built. And then from there, we can jump straight to learning. The key part is not to just mindlessly read the code. And if you've ever done a lot of code reviews, you will understand that it does get easier over time, the more and more that you review. And AI also has a pattern to how it writes code. So if you start to understand that pattern, you will start to understand that code a lot easier. And over time, this just gradually gets better. And everyone talks about AI slop. And to be honest, like I've seen AI write much better code than some humans. It's trained on all of our code as humans. Yeah, it does some strange things sometimes, but generally speaking, if it's given good guidance, it's going to write good code. So we follow this as a process and a loop. So AI writes code. We try to understand messages in that code, and we're going to talk about that more. What is a message? And we try to learn the concepts, not syntax. And then understanding arrives through repeated exposure to that code or to that process. How do we get there? We have to go back to Japanese again. And if you don't like Japanese, then sorry, this isn't a great video for you, but we do talk about it quite a bit because it's fundamental to this learning process, specifically AJAT. AJAT is a method of language learning. This is defined as all Japanese all of the time. And it's become very popular in recent years because of the foundational skills it gives you to have native level speaking or understanding of the language. And that's really what we're looking for. We're not looking for a basic understanding. We are looking for a native level understanding of that thing. There's a few things we can do in AJAT that help us do this. So we surround ourselves with the language. For me, that was YouTube, anime, music, going to Japan often. I would do language classes, language courses. All of these things together is immersion. This is surrounding yourself all of the time with the language. And it's really in the name, all of the time. If you're not in that language, you are not learning because you are not understanding messages. And this is where we're going to dive into this a little bit, understanding messages during exposure. So your goal is not to understand everything the first time you read it, but through repeated exposure, then you start to understand the bigger message every time you see that thing. And they say on average, it takes you about 7 to 10 times hearing or seeing a word to understand it. And we can do the same with code. The goal is to understand messages in that code, not to understand everything. And over time, your memory is going to expand and you're going to learn more and more. Learning fundamentals with the correct context. This is absolutely critical, especially in language learning, where things like grammar is how you sound native. You want to learn pitch accent, you want to learn grammar, you want to learn correct sentence structure. And if you're just reading a textbook or following a YouTube tutorial, you're not going to get that correct context. You need to get that from native speakers or from native content. So similarly, we use AI in coding for that native content. We can have it write most of the code for us. We just review the code. We make sure we are learning from reading the code. We're not going through it lazily and just skim reading it. We're trying to understand the functionality of the code so that we can understand the correct context. And then fluency arrives through exposure and understanding messages in the language. And it's the same as it is for language as it is for code. So when we're learning Japanese, we would focus on reading content or absorbing content that's sat at about an 80% knowledge base. So if we want to learn new skills, if we want to understand new messages, we had to look for something that contained between 5 and 20% of content that we didn't fully understand, because that's how we absorb new knowledge. That's how we are gradually taught new concepts in a language. Continuing on from that, we're going to look at a kanji that is quite common in Japanese. It's one of the first ones that you learn, and how you can use that in coding as well to help you with your fundamental knowledge. At the start especially, this becomes really, really handy. And as you grow your skills, you will find that you can recognize larger patterns in the code that can follow this same sort of flow. Okay, so this kanji is a common kanji seen in Japanese that's pronounced ki, and it means tree. There are multiple other meanings for it, but all you need to understand is that this kanji here means tree. Now, if you don't understand it, that's fine. We're not learning Japanese here, but this will help you with code. You don't understand this by memorizing keystrokes. Now, I can tell you that Japanese is very particular about keystrokes because you have to go a certain direction. It's usually, I think it's top to bottom, left to right. Then you would do these ones, and that's how you would perform that stroke. You don't need to understand that in the same way you don't need to understand how to write a function, how to write arrow functions, how to do classes, how to do different variables and consts and lets and those sorts of things. You're not memorizing keystrokes, you're memorizing functionality and the actual knowledge part. So we can use mnemonics and pictographs to understand these things. I think I spelled that wrong. You learn this stuff by understanding messages and using these methods to advance your skills. So if you look at this kanji, for example, we use this as a mnemonic or a pictograph. And what I mean by that is that we can represent this as an image rather than as a word or a kanji. Because if we don't have any understanding of what this is, then we're not going to remember that these lines in combination are tree. That doesn't really help us. But if we think about, well, this kind of looks like a tree. We've got a trunk, we got some branches, got some other branches hanging down. We can make these into a nice tree. And then we think about that as a concept rather than this just being a kanji or a single of over 2,600 characters. We think, well, this is a tree. We can visualize that as a picture, and we can do the same thing with code. If we see an arrow function, then, well, okay, that's all of a sudden that's a pictograph. Like this thing to the right, it's like, okay, equals whatever to the right. We've got a pictograph in an arrow function. So again, like this is how you can use these concepts from language learning in software, and you can take that and through repeated exposure, again, you're going to understand greater messages in what you're seeing. You don't need to remember it the first time. This is a concept that is going to be totally normal. In language learning, we dive straight into absorbing content. And even at a beginner level, I had a 0 level understanding of Japanese, and I would sit there and watch anime and I wouldn't understand a word. I didn't put English subtitles, you put Japanese subtitles. So you're listening to it in a foreign language with foreign subtitles because you need to understand the sound, the pitch accent, all of the different concepts of the language. And it's the same with code. You can do that with code. It's a little bit harder with code because there's no sound. There's no understanding being portrayed in a visual sense of what's happening on the screen if you're watching something, but it can still work. They say if you read Harry Potter in Japanese at a beginner level, by the time you finish reading all 7 books, you will have an advanced level of reading in Japanese. So you don't need the picture, you don't need what's happening on a video. You can just do it through a single sense. And that's all we're trying to do here. So the old way would be to learn the syntax first and try to understand what this thing is. Functions are a pretty easy concept to understand, but you would do this by drilling it in, right? You would go function, you would go add your curly brackets, you would add your braces, and then you would be like, okay, that's a function. I understand fundamentally that, yeah, cool, we would put some stuff in here and it'll do a thing. But this is an easy one to memorize. But over time, yeah, you get arrow functions and all the different ways you can do that. But conceptually, you don't even need to know that now. So your friction is actually much lower to understand a function. All you need to understand is that a function, it's a repeatable way to do the same thing. You don't even need to understand the syntax of this. You just need to understand the pictograph in this. And that pictograph right now is two curly braces with a curly boy. That's all you need to understand for this pictograph. This is a function. Obviously, as they get more advanced, it does add to that, but that's at a low level, that's how you understand what this does. So understanding the message in this code is understanding that this is a structure of a function. You don't need to know every keystroke anymore. Now, again, it goes over here. Like, this is exactly what we need to think about. We don't need to think about the syntax. How do we use language learning while we're coding with AI? So with language learning, we are mostly looking at exposure. Again, anime, music, immersion, anything that gets us more language. Obviously, the best thing you can do for language learning is go to the country that speaks the language. Sometimes that's not possible. So you just want to take in as much as you can. And it's the same with code. You want to take in as much code as you can in different contexts and different formats. So reviewing different code from different agents, reviewing different formats. Like, I quite often would just go look at other people's repositories on GitHub and review some of their code structures and see if I can learn anything from that. Not only is that going to help you as a developer, it's also going to help you long term while you're building these things, because you're going to find patterns that are commonly used that you might not know about yet. Secondly, in language learning, we want to make mistakes. It's encouraged to make mistakes. So when you see other people making mistakes or you make them yourself, then you would address those. And it's the same with software. If you run into errors, if you run into problems, then the AI can help you debug that. You can debug that yourself, and you're going to get more exposure to errors. You're going to understand them more. And natural patterns through repetition. Again, this is huge in language learning. You're not going to sound native. You're not going to communicate in a native way if you don't have the natural patterns of language. And it's the same with code. Understanding different formats and structures will give you a better understanding. Again, this isn't going to help you with actually typing the syntax. There is typing syntax tools for that. So if your goal is to be able to type code, then I recommend you go and learn those. Don't learn syntax from writing code yourself. Use the syntax coding tools and then understand the code through this format. Grammar internalization helps. So think about like grammar in the same way as code. Would you want to use a coding structure where you have bad named variables or poorly structured code or poorly structured files and folders? Like, it's the same thing. Grammar in language is a fundamental thing. Yeah, you can succeed in communicating without grammar, but it does add complications. It does make it harder. And at the end of the day, we want to make this as easy as possible. So similarly, software knowledge clicks without drilling syntax. So we're learning grammar through exposure. We're learning good practices for file and folder structures. So language exposure in terms of software just means reading more code, reading it in different contexts, understanding different functionality, surrounding yourself with the code, and using the tools that you have available. So for me, the biggest thing I've found that's helped me with understanding advanced coding principles is just the exposure. Like, the understanding I have now is way, way better than it was before AI tools, because I'm focused on learning the meaning of these things, not the syntax. For me, I can dive into almost any language of any code and I have a fair idea of what it's doing. I'm not going to understand everything in the same way that I don't understand every piece of Japanese that's spoken. I'm learning more every day, and by understanding this method, then you can encourage yourself to learn more as well. Again, we're focused on functionality. We're not focused on syntax. Focus on what the code does. That's the critical part. Holy cow, I'm getting good at these lines. Don't focus on the keystrokes. Just focus on the actual understanding. And use the tools. Like, ask AI to explain these concepts. Like, it's going to help you. It's going to give you a good guide, but you have to be proactive about that. If you go to the AI and just say, hey, can you explain this? It's going to do a pretty poor job. If you don't understand things like Booleans or cont or a specific concept, ask for that to be explained, not just a general understanding of the code. If you focus on those smaller messages, then the AI is going to get better, and you're going to get better as you use it the same way. So after exposure, the second thing is it's actually good to make mistakes. Seeing bugs, understanding those things, understanding messages in those bugs is going to help you. There are very few bugs now that I don't at least have a basic understanding of what it is. Generally speaking, I don't need to know. I'm able to have the AI assist me with resolving the bugs, but at a low level, I understand what the bug is and how to prevent it in the future. Generally, the reason it's reintroduced is because the AI has made the same mistake. There is actually situations now where I've seen a bug made so many times that I'm able to prevent it based on the input I give it. You're going to learn that over time as well. You don't need to understand an error the first time you see it. Exposure builds that recognition and it allows you to understand messages. And in Japanese, this is a similar way. Like we mishear a word 10 times before it might sound normal. And it's the same with coding errors. AI can explain an error or a method definition. The exposure is the learning, not the fix. So just remember, you want to focus on the learning, not fixing the bug. For concepts 3 and 4, these are smaller concepts to understand, but they're going to help you reinforce the first two. Understanding what the code is doing. If you don't understand what the code is doing the first time, that's fine. But if you're finding that continually not understanding what a simple coding concept is doing or what a simple function is doing, then you need to focus more on your exposure and actually focus on understanding those messages. If you're just blindly reading it and not really trying to learn anything, then you are not really going to go anywhere with this. You might see a function appear 100 times before you would even study that thing. Well, maybe you should have. Maybe you should go back and think, hey, I see this a lot. This is something I need to learn. And it's the same in language. Like we don't jump into advanced vocabulary. We will learn the 500 most common words first. Then we will learn the next 500 most common words first. So if you see a function written 100 times, perhaps you should dive into what a function is and how it functions. And again, repetition is the learning. You want to expose yourself as much as possible. And that's not just to say that repetition on its own is helpful. You want to see different concepts. There's different ways to write functions. There's different ways to do different things. You can have arrow functions, you have higher order functions, you have variable functions. There's so many different ways you can write a function that having exposure to all of them will help you understand fundamentally how that thing works. And then for concept 4, it's just understanding how the concepts of software work as a whole. If you have a basic understanding of all of these different bits, you start to grasp things like the language as a whole. In Japanese, there's a lot of nuance around being respectable, and they have different concepts for different levels of respect that you would use with certain people. And software's the same. There's certain things that make sense at the right time. You're not going to go and use an object if it's something that should be a type or a class, for example. You will learn those things over time, and reading code is how you understand those messages. Given the knowledge and the tools that we have today, this is how I would learn to code if I was starting from zero. First of all, I would focus on building. I've put that as point 4, but all of these are things that are going to be emphasized more if you are building something real. I'm not an advocate for vibe coding. I think that it has a place, but I think you should use it for learning and developing your skills, not for just trying to build something blindly, because that's a whole nother video. But start small. Don't dive into like advanced syntax or advanced programming concepts when you are brand new to this. Like everything is going to be very easy to misunderstand. Everything is going to be complicated. You're not going to really know what you're looking at or what you're doing. So yeah, rely on these AI tools, rely on Google, ask some people in communities. Like you can take all of this stuff, you can use it as a learning experience. Start small. Don't try to build Facebook. Start with a simple program that solves one particular thing for you. And focus on simple concepts like what is a Boolean, what is a function, what is a variable. And if you're already in an advanced level, then you can continue down that path. What is async? What are classes? What are interfaces? and then get into patterns and different recognition of different formats of code. Like there is so many different things you can do here that you can use. Be proactive about this. So number 2 is you have to do this. If you're lazy, if you're not proactive about reading code, you're not learning, you're not uncomfortable, and we learn the best when we're uncomfortable. So ask the AI to write a simple script and read it. You can read every line, but you want to understand the code. You don't want to understand the syntax. If you're not sure, ask the AI what it does. Use the habit of reading code, not just executing the code. And like I said, comfort in discomfort. You're not learning if you understand everything. And in language learning, this is 80 to 90% understanding. You will learn the most when you understand most of what you see. There's only 1 or 2 concepts that you don't understand. And this is very, very obvious in language, where you might hear or see a sentence that's given to you, and you know most of the words. And just based on the context, you can understand what the last 2 words mean, and then that's where you have learned a new word or a new concept. And again, just build stuff. Like the best thing you can do is build stuff, but don't blindly build things. There is a caveat here, like immersion isn't perfect, and that's the shortcoming of this, especially with language learning. Don't discounting what you learned before you started doing AJAT or before you started doing immersion-based learning. And for me, that was learning the first 500 words, learning the first 1,000 words, because without that foundational knowledge, it's not going to help you. You're still going to understand nothing of what you see. And it's the same for code. You need to use this with supplemental materials. And for language learning, that would be things like a grammar book, keywords, like the first words, like I said, in software. Yeah, use those coding videos to help you understand what these basic things are, like variables, functions, loops, things like that. But once you have a basic concept of the functionality, then dive into the actual product and building things yourself. Try to be aware of your own blind spots, things that you don't know that might trip you up in the future. And again, this is something where exposure is going to help you with that. You want to find those blind spots, but without exposure, you're not going to see them. Try to think language agnostic. Something in Japanese that I really liked was the fact that there are 750 words that are also used in Chinese and Korean. They share the similar kanji, or they share the same kanji. Some have different meanings, but that gives me a head start if I want to learn Chinese or Korean in the future. And it's the same with software. You're not trying to reinforce the exact patterns. You're trying to reinforce the fundamentals of software development. This will give you a better understanding of engineering skills as well. You're going to understand how things are built better, and you're not going to be focused on memorizing syntax. You're going to get better at reading code, which is going to be the biggest skill you can have in the future of these AI tools. If you can recognize a bug that the AI has missed, that's value that you're presenting. Some of the other things that it's not very good at is typing. We went over that. But your goal isn't to type. If you need to type, use those typing programs for learning how to type software. And I put here in brackets, like immersion makes you effective. Intentional curiosity will make you excellent, because that's totally true. Like immersion is going to help you understand more, but you have to be intentionally curious. If you're not intentionally curious, you're going to get to a plateau that's not going to be easy to overcome. And you really have to push yourself. And it's the same with anything you learn. Like you can take these fundamentals and put it to anything else. So I want your mental model to shift a little bit. When you're watching a tutorial, in the past, you would typically have your IDE open in another window or another monitor, and you would type exactly what they type, and you would try to implement that thing. Instead, the first thing I want you to do is I want you to go to those same videos, and rather than typing exactly what you read, just listen to what they're explaining, because all of these videos are giving you the same explanation for what these things do. And if you don't understand what they're typing, then you need to go back a step. If they're typing functions and they just gloss over, oh, this is a function that does this thing, but you don't even understand functions, you need to go back to a more fundamental level to understand what a function does. And that's where like the pictograms come in. Like a function is a repeatable way to do the same thing. We know that because we learnt about the kanji and we learnt about the pictograph for a function. You don't need to know more than that yet. Again, you're going to get more exposure, you're going to learn more. In this video, we went over a really quick foundational knowledge of what AJAT is and how it applies to software and learning anything now. I am probably going to get a lot of hate for this because it's completely new and no one is talking about it, but I do think this is the future of learning to code. So if you agree or you disagree, I would love to hear about it in the comments. I genuinely think this is the future. And I think those that adapt to this are going to have the best experience in software, in learning anything in the future. Like AI is such a powerful tool, but it is exactly that. It is a tool. It is not going to replace us. It's how we use that tool that's going to make us more effective. Yeah, if you want to see more, hit the subscribe button, and thanks for watching.